Hello, my name is Ken Wright. In this presentation, we will be talking about the dual nature of light as both wave and particle. This is considered by many scientists to be contradictory. Yes, even paradoxical. But why? All waves in nature are both wave and particle. But all waves in nature have a particulate medium, a medium made of particles, except light. We're going to talk about this later, but first, I want to spend a minute or two on the wave and particle features of light. Light is a transverse wave, which means that its wave motion is perpendicular to its direction of travel. When I use the term light, I'm talking about a whole range of wavelengths and frequencies known as the electromagnetic spectrum. Not just that tiny portion of light that we can see with our eyes. As you can see in this picture, the color band is bounded on one side by infrared and on the other by ultraviolet. And the visible portion of light is a little smaller than an amoeba, a little larger than a virus. Wavelengths of light are measured as the distance between two wave crests. And these wavelengths range from lengths larger than football fields down to lengths smaller than the nucleus of an atom. Let's talk now about the particle nature of light. I have a light source of a certain frequency that shines photons onto a metal plate. The force of the photons knocks loose electrons, which can then be channeled into an electric circuit, which can be used to light light bulbs, charge batteries, all sorts of things. This is called the photoelectric effect, for which Einstein received a Nobel Prize. A wave, by definition, is a disturbance in a medium. If the wave has a particle nature, which all do, it is because the medium is made of particles. Consider ocean waves. Ocean waves have a medium called water. Water is made of particles called water molecules, or H2O. It is the same with sound waves in air. It is air molecules that carry the sound in the medium of air from its source all the way to your ear. Without air, there would be no sound waves. Without water, there would be no water waves. Scientists in the 19th century believed that there had to be a medium for light waves, which they called the luminiferous ether. But experiments failed to detect the ether. So Einstein did away with it as he developed his theory of relativity. But failing to find something doesn't mean that it doesn't exist. In our current understanding of what our universe is made of, we haven't discovered most of it. Dark matter has been hypothesized to account for more gravity than is detectable from the matter that we have found. But we haven't detected the dark matter. Dark energy has been postulated to account for an accelerating expansion of the universe. But we haven't found dark energy. That's over 95% of the universe that we haven't found. So, how can light be both wave and particle without a particle medium? Well, if you watched the opening presentation, the introduction to this series on light, I quoted a passage of Scripture from a sacred text called the Doctrine and Covenants, section 88, verse 11. And this passage seems to suggest that the physical light that we can see with our eyes is the same light that inspires our minds. Just two sides of the same coin, so to speak. Thus, if there is a spiritual light that is substantive, there is no mystery. Whatsoever is light is spirit, even the Spirit of Jesus Christ. All spirit is matter, but it is more fine or pure, and can only be discerned by pure eyes. If this be true, then light is like other waves in nature. Just as water is its own medium for water waves, light is its own medium for light waves.